Today is our last day of new material before test 2. Okay, so we're going to talk some more about inverse functions. We started right before the break. We're going to finish talking about inverse functions. Project 2 is due today. That's your transformations project, so put that in your folder before you go. Wednesday we'll review for the test, and just like with the previous test, you have a study guide at the back of the packet that we've been working through, and solutions to all the practice problems for that are posted in YouTube. There's a link to the playlist in Moodle. And then Friday is test 2. Okay, Friday is test 2. I won't be here Friday. Linda Kavanaugh will be proctoring your test, just so that you aren't surprised. Okay, so let's go through the preview exercises. There was some really good discussion here in terms of the preview exercises. So I have a relation that's defined by just 4 points. Okay, so what is the domain of this relation? Close. No. The domain is a set of all x values, right? Yeah, it's -2, -1, 1, and 2. Why is that different from saying -2 to 2? Yeah, that includes all the numbers between the integers, like 1.5, right? Which is actually not part of the domain. Okay, so that is, you just have, when it's just 4 points, you just list the x values individually. Okay, and then what's the range of this function? Or relation, I should say. 1 and 4. Those are the only two y values. Okay. All right, so now I just want to reverse the components of each ordered pair, and that's all an inverse function ever does. That's all an inverse does. It reverses x and y. The definition of an inverse function is that it changes x's and y's. So my points are now going to be 4, -2, 1, -1, 1, 1, and 4, 2. All right, what is the domain of this function, or this relation? 1 and 4, yeah. What is the range of this relation? -2, -1, 1, and 2. Those are all the y values of that relation. Okay. Is the inverse relation a function? So looking at this set of ordered pairs, when I swapped the x and the y coordinates, is it a function? No, why not? Yes, there is an x value that has more than one y value. In fact, there are 2 x values that give more than one y value. Okay, so this is a big old no, right? Because my x value, when x is 1, I have 2 y values, 1 and -1, right? And when x is 4, I also have 2 y values that are associated with x equals 4, 2 and -2. Right, so I have 4, -2 and 4, 2. The definition of a function is that each x value can be paired with only one y value. So if you have more than one y value associated with an x, it's not a function. And it only has to fail one time, right? And it's no longer a function. You just have to find one x value that has 2 y values, not a function. All right, so we define a function whose inverse is also a function. We call that special kind of function one-to-one. So is this function that we've been talking about since the beginning here, is it a one-to-one function? No, because it's in, when I took its inverse, we said that was not a function. So this is a no. If after I had reversed the components I had gotten a function, we would have said yes, it's one-to-one. Okay, So, does every function have an inverse function, and how can we tell? That's what we're going to talk about today, or what we're going to start with. So to answer the question, I'm going to look at two functions. F of x equals x plus 1, simple line, and g of x equals x minus 1 squared, which is a parabola. So here are four possible solutions for f of x equals x plus 1. These are 4 points on that curve. And then if I reverse the components of them, which is what you do when you find an inverse, just reverse x and y, okay, I get these 4 points. So this is a function. Is the inverse a function? According to these 4 points? Yes, each x goes to exactly 1 y, so this is also a function. Okay. So it looks like for x plus 1, different inputs produce different outputs. The inverse of f is also a function. FCN is my abbreviation for function, yes. All right, let's look at 4 points on the graph of x minus 1 squared. So I've got negative 2, 9, negative 1, 4, 0, 1, and 3, 4. When I reverse the components, so I just take the x's and y's and swap them, I get these 4 points. So this one was a function. My original is a function because each x corresponds to just 1 y. But what about the reverse? No, where is my problem? Yeah, the 4, negative 1, and the 4, 3. I have the same x value corresponding to 2 different y values. That makes this not a function. Okay. So for the function x minus 1 squared, the inverse is not a function. So when we swapped the inputs and outputs for our functions f and g, we noted that the inverse of the linear function was a function, but the inverse of the quadratic function was not a function. Can we look at the graph of a function and tell if it has an inverse? Okay, so I'm going to add a little color here. So this is my parabola G, and then this is my line F. Okay, if I draw a horizontal line, y equals 4. Here's my horizontal line. Y equals 4. Okay. How many times does that blue line intersect the graph of F, the green line? Once. How many times does that horizontal line intersect the graph of G, the pink parabola? Twice. Okay, so we have this thing called the horizontal line test. It says if any horizontal line, such as the one we just drew, right, intersects a graph at 2 or more points, then the graph of the function will not have an inverse function, and the function will not be one-to-one. So we call that the horizontal line test, HLT for short. All right, so now we can decide whether or not a function has an inverse function. And then once we know whether it has one, we're going to learn now how to find it, okay? How to find a formula for it. So I want to find the inverse of a function algebraically. If a function is defined by an equation, we can obtain an equation for f inverse by interchanging the role of x and y. Okay? So this is exactly what we've been doing with numbers, like we've just taken points and swapped the x and the y. Now we're just going to swap the letters x and y. Your textbook refers to this procedure as the switch and solve strategy. So here's how it works. I've got a function f of x equals 5x minus 6. If you graphed 5x minus 6, what would it look like? Yeah, it's a line. So is it one-to-one? Yes, it will have its inverse will also be a function. So it has an inverse, we can find it, right? So verify that the function is one-to-one. Usually you do this just by looking at a graph or knowing what its graph looks like via transformations, right? So our f is a line, passes HLT. So f is 1, 2, 1. Okay. All right, so that means we can find its inverse. I can now go about the process of trying to find a formula for the inverse function. So it says replace f of x with a y. So this is going to become y equals 5x minus 6. Just a simpler notation. Now interchange x and y, because this is essentially what inverse functions do. They make x's y's and y's x's. So instead of y equals 5x minus 6, wherever I see a y, I'm going to write an x. And anywhere I see an x, I'm going to write a y. Then you solve for the y. Right? So I'm going to add 6 to both sides, divide both sides by 5. So I get y equals x plus 6 over 5. That is my f inverse function. Okay, and typically you'd use the notation f inverse of x once you've done that. So swap x's and y's, solve for y, switch and solve. To verify that two functions are inverses, you just have to show that they give you a round trip. When you plug one into the other, you get x back. Okay, so I want to plug f inverse into f. So this is a good review of what we talked about at the end of last class, which I know was over a week ago. It was like a week and a half ago. So let's go through it together slowly. Okay. So I need to compose f with f inverse. F of f inverse of x. Okay. So you work from the inside out. So this says you're going to plug f inverse into f. Okay. So my formula for f is just 5x minus 6. So when I do f of some stuff in parentheses, that means to replace all the x's in my formula, 5x minus 6, with the stuff in the parentheses. So I'm actually going to put in an f inverse here. But what is the formula for f inverse? X plus 6 over 5. So this is going to be 5 times x plus 6 over 5 minus 6. My 5's are going to cancel here. And then I have x plus 6 minus 6, which is x. Right, which is what I was hoping to get. That's what inverse functions do. When you compose inverse functions, you get x back. Let's do it in the other order. Okay, let's see what happens if I do f inverse of f of x. Okay. So again, you work from the inside out. So this says I'm going to plug f into f inverse. So I'm going to start with my formula for f inverse, which is x plus 6 over 5. But I'm not going to put an x there. What am I going to put there? F of x, because that's what's in the parentheses here. Okay, and then the formula for f of x is 5x minus 6. So I have 5x minus 6 plus 6 over 5. Minus 6 plus 6, those cancel. 5x over 5 reduces to x. So we got x going in both directions. That proves that we found the inverse formula correctly. Yes. All right, so that's it for the lecture portion of the class. And you get some activities to practice identifying whether a function has an inverse function and finding that inverse function algebraically.